Welcome to our presentations. We are Group 8 from the Chemistry Education Program at 11 Maret University, and this presentation is a part of the Capita Selecta on Senior High School Chemistry. We will discuss an interesting topic: common misconceptions in reaction rates and chemical equilibrium. In these presentations, we aim to uncover common misunderstandings, provide scientific clarifications, and offer effective learning solutions. The members of our group are Putri Rahmawati, Vini Qushori, and Vivi Maulida. First, we would have to know about reaction rates. So, what is reaction rates? The rate of reactions can be expressed as the decrease in the concentrations of reactants per unit time or the increase in the concentrations of products per unit time. When someone said the rate of irreversible reactions is higher with time, is that true? So, what is the correct concept?
Sulfur and oxygen are the reactants, and sulfur dioxide is the product. To understand the process, it can be illustrated with a chemical tube in which there are a number of sulfur atoms and oxygen molecules. To understand the process can be described with a chemical tube in which there are a number of sulfur atoms and oxygen molecules. Both substances form sulfur dioxide molecules. Visually, the amount of sulfur and oxygen continues to decrease while the amount of sulfur dioxide is increasing. This change causes a change in the molar concentration of sulfur, oxygen, and sulfur dioxide. For an irreversible reaction, the rate of the reaction does not increase with time. In fact, as the reaction proceeds, the rate typically decreases over time. Here's why. The first one, in an irreversible reaction, reactants are converted into products, and as the reaction proceeds, the concentration of reactants decreases while the concentration of products increases. Second one, the rate of a reaction generally depends on the concentration of the reactants. In most cases, as the reactant concentration decreases over time, the rate of the reaction also decreases. And the last one, the rate of an irreversible reaction is typically faster at the beginning when the concentration of reactant is highest, but it slows down as the reaction progresses and the available reactants become fewer.
The rate of reaction slows down as the concentrations of the reactants decreases, which can be likened to a person running. At the beginning of an activity such as running, a person has a lot of energy so that she can move quickly. However, over time, energy is depleted and the person becomes slower. The second one we will discuss is about chemical equilibrium. So, what is chemical equilibrium? Chemical equilibrium refers to the state in irreversible chemical reactions where the rates of the forward and reverse reactions are equal, leading to no net change in the concentrations of the reactants and products. When someone said that under the equilibrium condition, rate of the forward reaction is faster than rate of the reverse reaction. Is that true? So, what is the correct concept?
The forward reaction rate continues to decrease, while the reverse reaction rate increases. This happens until the forward reaction rate is equal to the reverse reaction rate, and the concentration of reactants and the concentration of products does not change significantly. In this state, the reaction has reached equilibrium. At chemical equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. This dynamic balance means that while the forward and reverse reactions are both occurring, they do so at the same rate, leading to no net change in the concentrations of reactants and products. In other words, although individual molecules are constantly being converted from reactants to products and vice versa, the overall concentrations remain constant because the rates of the forward and reverse reactions cancel each other out.
The water cycles describes a dynamic system, such as the forward and reverse reactions in a chemical equilibrium system. The total amount of water in the system remains constant at the point because the two processes occur at equal rates. This is similar to the state of equilibrium in a chemical reactions, where the amounts of reactant and products do not change because the rate of the forward and reverse reactions are equal. Here's we got the conclusions. In the rate of reactions, the rate of irreversible reactions is higher with the time. That is misconceptions. And the true statement is the rate of irreversible reactions is lower with the time. The second one, in chemical equilibrium, under the equilibrium condition, rate of the forward reaction is faster than the rate of reverse reactions. That is a misconception. And the true statement is under the equilibrium condition, rate of the forward reaction is equal to the rate of the reverse reactions. And we know that misconceptions in rate of reactions has an impact to the misconceptions in chemical equilibrium. Thank you for watching our group presentations. We hope that what we shared can provide valuable insight and be useful for everyone.